Let's begin our topic on chemical kinetics. The term kinetic energy means energy of motion. When we think of that word kinetic, we're thinking how fast reactants are turning into products. It's usually measured in something called molarity per seconds. How quickly something is disappearing is the rate at which reactions are measured. When a reaction is said to be spontaneous, it doesn't necessarily tell us how quickly the reaction is occurring. Our car, for instance, made of steel, will rust. It is a spontaneous reaction. That particular reaction could take many, many years to actually see a product occur. Some reactions occur within split fractions of a second. We have radioactive decay, for example, of large elements past uranium on the periodic table that are so unstable, their process of decay occurs in thousandths of a second. That's a very quick reaction. So that term spontaneous doesn't give us an indication of how long, just the fact that it is occurring. The term kinetics, then, the topic of our chapter, is referring to how quickly a reaction occurs. And what are those things that we could do to control the speed? If we want a reaction to go faster, what might be some ways to manipulate the equation to increase its speed? Or if we're trying to control a reaction, what could we do to slow it down? So the topic of kinetics, how fast a reaction is occurring. In our notepad then, we have a chapter 14 on chemical kinetics, and between the PowerPoint slides and the notepad, we'll be filling those in together. It says we study kinetics by studying reaction rates. How quickly a reaction is occurring, the study of kinetics. Spontaneous reactions. The word spontaneous means that the reactions are happening, but not any indication of how fast those reactions are occurring. Another topic in our chapter, how do the reactants actually turn into products? The step-by-step reaction mechanism will be discussed as well. Knowing the speed of a reaction gives us great insight into a reaction mechanism. And again, more on that, but most reactions occur in a multi-step process. Knowing how quickly a reaction occurs or how slowly a reaction occurs allows us to propose these pathways called reaction mechanisms. There are many things we can do to manipulate the effect of reaction rates. What are some things we could do to speed up or slow down? Well, one of the factors that says the physical states of reactants. The physical states of reactants determines, are they solids, are they liquids, are they gases? What are those physical states? We know that more readily that molecules can collide with one another, the more rapidly they react. They physically have to come into contact with each other to cause reactants to turn to product. So I can see gases and liquids. Those are solutions that are easily mixed. Gases with complete freedom to move around, they're going to collide more often, and therefore reactions will occur faster. Solids, of course, are limited to the surface area for their reactions. Crushed powders actually have a faster reaction rate than larger tablets. So again, crushing or liquefying or creating a gas will increase the rate of a reaction. If we think about the collision theory, and just that simply stated says, in order for a reaction to occur, molecules have got to collide with one another. That's how bonds are broken and new bonds are formed. We can affect the reaction rate by manipulating the concentration of our reactants. If I put more in, I'm more likely to have a collision. So if the concentration increases, more solute is provided. We have a frequency at which reactant molecules collide increases, and that would thus lead to a faster rate. The more stuff, the more likely they are to collide. A third way to manipulate a reaction rate is to control the temperature. Most often when we increase temperature, the reaction rate increases as well, simply because those molecules possess more kinetic energy. More kinetic energy means they're moving faster, and more collisions will occur with that higher energy. And on the flip side of that, it's why we refrigerate foods. If I place them into a cold environment, the reaction rates slow down, the process of spoiling is inhibited. The fourth thing we can do to affect the reaction rate is the presence of a catalyst. Catalysts are not heat, but they're actually ingredients that we add to actually alter the pathway of a reaction mechanism to speed up a reaction. If we think about an energy profile, and I'll just draw a typical exothermic reaction, we start with reactants, and over time, we go to products. And just think of this really as, let's just call this energy, kinetic energy, versus time. If the reactant start at a certain energy, they must climb a certain barrier known as activation energy. How much energy do we have to input to cause the reaction to occur? And that term is called activation energy. If there's a large barrier, not many molecules make it over that hill, and we have a slow reaction rate. If we have a smaller energy barrier, a lower activation energy, more molecules meet the requirement, and we have a faster reaction rate. A catalyst works by lowering the amount of activation energy. It actually provides an alternate pathway for the reactants to find the products. If we have a smaller activation energy in the presence of a catalyst, we will increase the rate of our reaction. So the four factors that affect reaction rate, the physical states of reactants. Are they solids? Are they liquids? Are they gases? We know the more energy they have, such as gas molecules, the more likely they are to collide. Number 2, the concentration of reactants. As concentration increases, we're more likely to have collisions, and therefore rates will increase. We can increase temperature, causing more energy in those molecules to collide more frequently. Or the fourth one, we could add a catalyst to speed things up. A catalyst is a chemical that we add. It is not a reactant, not a product. It's just there to change the pathway, to change the mechanism in which the path occurs. Lowering the activation energy increases reaction rate.